Here is an example from textbook. You can pause this video and read the question. Explain why the distribution of random variable x can be modeled by the binomial distribution. There are three properties of the binomial distribution. First, each byte or trial has two possible outcomes, win or lose. Second, each byte, there is a constant probability of winning, which is 25%. Last, each byte is independent, and there is a fixed number 4 of independent trials. Find the probability that you win exactly 2 bytes. We need to use this formula. The n equals 4 because there are 4 items available on eBay. X equals 2 because we are trying to find the probability that you win exactly 2 bytes. The p equals 0.25 because for each byte you have 25% of chance winning it. And this also explains why the probability of failure is 75%. Then you plug in all those numbers into this formula. Next, the full factorial should be calculated in this way. And the denominator will be the factorial of 2 times factorial of 2. So it should be calculated in this way. And as you can see, these two parts are exactly the same, so they cancel out. Then this ratio here will equal 6. Last, you can just use your calculator to finish this calculation. Please verify this by yourself. In Blackboard, I have attached a video about how to use calculator to calculate factorial. If you have an advanced calculator like TR-83 or TR-84+, you should watch it. The next question is, find the probability that you win 2 bytes or fewer. So using mathematical languages, you win 2 bytes or fewer is the probability x less than or equal to 2. This probability also equals to x equals 0 plus probability of x equal 1 plus possibility of x equals 2. And we just calculate these 3 parts individually. So first, we calculate the probability of x equals 0. Then for probability of x equals 1. Last, the probability of x equals 2. The last step is you add these 3 probability. Then you have the probability of x less or equals 2. This type of question will also show up in exam 2. Next question. Find the probability that you win more than 2 bytes. In the language of the mathematics, it equals to the probability that x is larger than 2, which equals to probability of x equals 3 plus x probability of x equals 4. Or it also equals to the probability of 1 minus the probability of x smaller than or equal to 2. Since we already found the probability of x less than or equal to 2, we can just plug in this number and then calculate the probability of x larger than 2. Another example from textbook. You can pause this video and then read the question. First, state assumptions needed for the binomial distribution to apply to the number of times he is successful on his next 5 requests. We need to check all 3 properties for the binomial distribution. First, assume the data is binary. You can either have success or failure, yes to the date or no to the date. Second, you assume the probability of success is the same for each call. You can find the probability here. Last, assume each call is independent of all other calls. If he asks the same woman each of 5 times, is it sensible to treat those requests as independent trials? Of course, it's no. Right? Remember that independent trials means the outcome of any one trial is not affected by the outcome of any other trial. So under the binomial assumptions, state n and p and the mean of the distribution. When n equals 5, we are looking for at the next 5 calls. The p equals 0.6, it means the probability of success was stated to be 60%. So mu should equal to n times p, which is 5 times 0.6 should equal 3. This means on average, he expects that for every 5 calls asking for dates, he will get a 3 yes response in long run. Extra question. A question has 4 possible answers, only one of which is correct. With 20 such questions, the distribution of the number of incorrect answers is binomial with n equals 20 and p equals 0.2. What is the probability that one will have 15 correct answers? So from the question we have n equals 20 and p equals 0.5. X should be the number of incorrect answers. So the probability of 15 correct answers equals the probability of 5 incorrect answers, because these 2 events are equivalent. So we use the binomial equation again. This ratio should be calculated in this way. And the last 2 parts, as you can see, the 15 to 1, the product from number 15 to 1 cancel out. And 0.2 here is the number, is the probability of 1 success. And we need to have, here the success actually means incorrect. So the incorrect answer needs to happen 5 times. And we need to have 15 correct answers. And the probability of 1 correct answer is 0.8.